All right, so we have these two that we want to solve. Now we're multiplying and dividing as indicated. All right, so let's do this. So for the first one, okay, we're going to multiply. Now, what I'm doing here is I'm factoring everything first. I'm mostly doing that because we want to simplify. So I'm just deciding to factor everything first. Okay, so if we were to factor, we have x squared plus 2 times x minus 8. Right, so here again, we want two numbers that, whose product is negative 8, but the sum is 2. The product's negative 8 and the sum is 2. From there, what we get is 4 and negative 2, right? Their product is negative 8. The sum is 2. So because of that, we get this is equal to this. We're just factoring. I mean, I know like in the other examples, I multiplied first, but if you multiply or factor first, it really doesn't matter that much because we're going to have to simplify anyway. Here, for this one, this denominator, we want two numbers whose product is minus 20 and the sum is 1. The product's minus 20, the sum is 1. Okay, what numbers do that? Well, we know 5 times negative 4 is negative 20. The sum we know is 1. Right? So let's use 5 and minus 4. So we get this. Okay. Finally, we have this one. I mean, the x plus 4, you can see we really cannot factor, right? You know, you can't break that down any further. So for this one here, this denominator, we want two numbers whose product is 4 and whose sum is 5. All right, which numbers do that? 4 and 1. They do that. 4 and 1. Okay, so now that we have everything factored, right, we can now multiply. You know, you're just multiplying denominators and numerators together. And what do we do next? We cancel common factors. So the x minus 4, as you can see, well, wait a minute, let me make that nicer. There we go. That cancels with this. This cancels with this. X plus 4 also cancels with itself. So we are left with this, as you can see. So if you factor first and then multiply, or multiply but then factor, either way you're going to get this answer. And so because of that, and so we get our answer. Yeah.
So I could be wrong, but so for x squared plus 2x minus 8, when you factor it, wouldn't it be x plus 4 and x minus 2?
Yeah, I messed up.
That positive 2.
Yeah, I think I made a mistake, didn't I? Yeah, on the other slide. Let me just fix. Let me fix that. Thank you. Let me just fix that quickly, everyone. Thank you. That's 4. Right, so there should be 2 of them up here. Okay. Thank you. Oh boy. Yeah, as you can see, there's a lot going on. All right, so let me just fix this. So it looks like we're going to have an x plus 2 4 over x minus 1. There we go. Thank you. All right, that should do it. Right, so yeah, that was my fault. So I factored incorrectly. Thank you for, thanks for pointing out. Thanks for finding my mistake. I appreciate it. I really do. Sorry. Okay, anyway, so what we have then is when you multiply, right, you have all this, as you can see. And because of that, so there might be a little less canceling, but they're still canceling. As you can see, we only lose an x4 from the top and bottom. And, wait a minute. All right. Oh, no, that's right. That's right. Sorry. I thought there was another mistake, but everything else I think is right. Okay. So these cancel, and we're left with this. All right. Okay. So that's good. So that's this one. Let's do the next one then. So for this one, we have, again, same idea. The only difference now is that what's going to happen is, since we're dividing, we're going to eventually have to take the reciprocal of this and then multiply. Just like before, I decided to factor first. That's okay. We have x squared plus 2x minus 3. Okay? And again, we want two numbers whose product is -3 and the sum is 2. How about 3 and -1? So what do we get? We get 3 and -1. They seem to work. Their product is -3. Their sum is -1, and their sum is 2. So we get this. Moving on, we have this one here. Right, that's the next thing we're going to factor. Now notice though, we want two numbers whose product is 16 and whose sum is 8. Well, what two numbers do that? We know 4 times 4 is 16. 4 plus 4 is 8. So we end up with this, as you can see. Okay, so that's what I have. X minus 1, you really can't factor anything out. 3x plus 12, you can, right? 3 itself is a factor of 12. So I factor out 3, and we get x plus 4. 3 times x plus 4. Hopefully I didn't make a mistake here, but I don't think I did. It's right to me. Yeah. Okay, so now we are, dividing. And again, when you divide, you have to take the reciprocal and multiply. And doing so, you can see that there will be some canceling here. For instance, the x plus 4s are going to cancel, and the x minus 1s are going to cancel as well. And so when the dust settles, you get this. That's what we get. Okay, I really hope this makes sense. I mean, yeah. I mean, it's definitely right. So, hope this makes sense to everyone. Any questions on this? All right. Okay, so that was multiplying and dividing. So I think it'd be good now to, at the very least, start adding and subtracting rational expressions. Just like we can add fractions, right? We can add, fractions and irrational numbers. We can add fractions of polynomials. The rules still apply, okay? The rules from adding rational numbers still apply here. Namely, you need a common denominator. Okay, you can only add if the denominators are the same. And just like we saw, when you actually do add, the denominator stays the same, and you just add the numerator. Same thing with subtraction. So basically, it's the same rule as with adding and subtracting fractions of integers. Rational numbers. And also, just like with rational numbers, you can really theoretically use any denominator you want, but there is a best choice, though. There is a so-called best